We'll start in about a minute. Today we'll be in Chapter 8, Section 4 on operations with radicals. We'll add, subtract, and multiply radicals. 1 week from today, we'll have Test 3 over Chapters 7 and 8 material. In Section 8.4, operations with radicals. First, we'll add and subtract radicals. Like radicals can be combined by adding and subtracting. Simplified radicals are called like radicals if their indexes, variable parts, and radicands are the same. Like radicals may have different numerical coefficients. So just to emphasize, we're defining here like radicals. So when they're simplified, they have to have the exact same indexes and variable parts, and the radicands all have to be the same. Okay, in this first example, simplify by adding or subtracting. Here we have 11 times the square root of 3 minus 7 times the square root of 3. First note that the square roots are as simplified as they can be. And since we're subtracting, we can combine by subtracting. So 11 times the square root of 3 minus 7 times the square root of 3 simplifies to 4 times the square root of 3. So this is analogous. I'll just write analogy. If we have 11x minus 7x, we know that that simplifies to 4x. So the same concept works when combining like radicals. In the next example, 5 times the square root of x plus 3 times the square root of x minus the square root of x. The square roots are all simplified, and we're adding and subtracting, so we can combine these like radicals. So from left to right, if we do this in steps, 5 times the square root of x plus 3 times the square root of x combine to make 8 times the square root of x, from which we are subtracting 1 times the square root of x. And then the final step is to write 7 times the square root of x. Okay, the next example, 14y times the cubed root of 9x plus 11y times the cubed root of 9x. The cubed root of 9x cannot be simplified further, and the two terms that we are adding have the same variable parts. There's a factor of y on the outside of each, and each one is the cubed root, has a cubed root of 9x. So we can combine by adding 14y times the cubed root of 9x plus 11y times the cubed root of 9x simplifies to 25y times the cubed root of 9x. So when we were adding, we just added the coefficients, 14 plus 11, to get the coefficient of the combined terms. Okay, the next example, 13 times m times n times the fourth root of 7r minus 10 times m times n times the fourth root of 7r. So the terms are like terms. On the outside of the radical, they each have m times n, and the radicals are identical. So when we simplify, we're going to get 3 times m times n times the fourth root of 7r. Okay, a couple of more on this page. On the lower left, 19x to the second times the fifth root of 12y to the third minus 3x to the second times the fifth root of 12y to the third. The fifth root of 12y to the third cannot be simplified any further. On the outside of the radicals, each of the terms has x squared. So when we simplify, what will the coefficient of the simplified term be? Okay, the coefficient of the simplified term will be 19 minus 3, which is 16. So 16 times x to the second times the fifth root of 12y to the third. In the next example, negative 7, a to the fourth, b to the fifth times the seventh root of 11c plus 10a to the fourth, b to the fifth times the seventh root of 11c. The seventh root of 11c, that cannot be simplified any further. So the radicals are like radicals. Okay, someone who hasn't answered a question yet, what's the coefficient of the sum for this one? Okay, 3. Negative 7 plus 10 is 3. And then we write down 3 times a to the fourth, b to the fifth, times the seventh root of 11 times c. Okay, now we'll look at some slightly more complicated examples. I'll just note that in each of these 6 examples that we've done so far, all of the radicals were as simplified as they could be. Hey, but we won't always start out with simplified radicals. In this example, 2 times the square root of 75 minus 9 times the square root of 48. The square root of 75 can be simplified further, so we have to simplify this term first. The square root of 48 can also be simplified further. So we also have to simplify that. And then after simplifying all of the radicals, we'll check to see if we can carry out the subtraction. Okay, so starting with 2 times the square root of 75, the largest factor of 75, that's a perfect square, is 25. So rewrite 2 times the square root of 75 as 2 times the square root of 25 times 3. And then we'll work on the square root of 48. The largest factor of 48, that's a perfect square, is 16. 16 times 3 is 48. So we write minus 9 times the square root of 16 times 3. I'll put in another intermediate step. It's not absolutely necessary, but so let's write the next step, 2 times the square root of 25 times the square root of 3, and then minus 9 times the square root of 16 times the square root of 3. The square root of 25 is 5, so we get 2 times 5 times the square root of 3. And then the next term, the square root of 16 is 4, so we have minus 9 times 4 times the square root of 3. Then the next step, 2 times 5 times the square root of 3 is 10 times the square root of 3. And then minus 9 times 4 times the square root of 3 is minus 36 times the square root of 3. We can combine by subtracting because the radicals are the same. So the final result, 10 times the square root of 3 minus 36 times the square root of 3 is negative 26 times the square root of 3. When you're simplifying these, you don't have to put in all of those steps, but if that's what it takes, then go ahead and use as many steps as is necessary. Okay, the next one, 2 times the square root of 45 plus 5 times the square root of 48 minus 3 times the square root of 20. All right, the first one, the square root of 45 can be simplified further. So what is the largest factor of 45 that is a perfect square? So if you haven't answered a question, go ahead and answer. Okay, the largest factor of 45 that is a perfect square is 9. 9 times 5 is 45. So we will rewrite 2 times the square root of 45 as 2 times the square root of 9 times the square root of 5. And you can verify by multiplying that it's correct. 9 times 5 is 45. Then the next term has the square root of 48. The largest factor of 48 that's a perfect square is 16. So we can rewrite this as 5 times the square root of 16 times the square root of 3. And then minus 3 times the square root of 20. The largest factor of 20 that's a perfect square is 4. 4 times 5 is 20. So we write minus 3 times the square root of 4 times the square root of 5. Okay, the square root of 9 is 3. So I will bypass an intermediate step and do it all at once. The square root of 9 is 3, and 2 times 3 is 6. So this becomes 6 times the square root of 5. The square root of 16 is 4, and 5 times 4 is 20, so we get plus 20 times the square root of 3. And then minus 3 times the square root of 4 times 5. The square root of 4 is 2, so minus 3 times 2 times the square root of 5 becomes minus 6 times the square root of 5. Okay, so the radicals are all simplified, but the radicals are not all like radicals. So we do have 6 times the square root of 5 minus 6 times the square root of 5. So those combine to make 0. So the final result is 20 times the square root of 3. Okay, the next one. So on this one, we have 4 times the square root of 18xy to the second plus the square root of 8xy to the second minus 5y times the square root of 50x. Okay, so to simplify the square root of 18xy to the second, we want to identify factors of this radicand that are perfect squares. 9 is a factor of 18, and 9 is a perfect square. 9 times 2 is 18. So x, the square root of x cannot be simplified, but y to the second is a perfect square. So we can rewrite this as 4 times the square root of 9y to the second multiplied by the square root of the remaining factors, which are 2x. You can verify by multiplying that you're doing it correctly. 9y to the second times 2x is 18xy to the second. Okay, well, let's work on the middle term, which is the square root of 8xy to the second. The largest factor of 8 that is a perfect square is 4. 4 times 2 is 8. So the square root of x cannot be simplified. Y to the second is a perfect square. So we'll rewrite the square root of 8xy to the second as the square root of 4y to the second times the square root of 2x. And then we have minus 5y times the square root of 50x. The largest factor of 50 that's a perfect square is 25. So we will rewrite the square root of 50x as the square root of 25 times the square root of 2x. Okay, so in the next step, 4 times the square root of 9y to the second. The square root of 9y to the second is 3y. So now we have 4 times 3y times the square root of 2x. And the next term, the square root of 4y to the second is 2y. So we have plus 2y times the square root of 2x. And then minus 5y times the square root of 25 times the square root of 2x becomes minus 5y times 5 times the square root of 2x. Okay, in the next step, 4 times 3y times the square root of 2x. This becomes 12y times the square root of 2x. The middle term stays the way it is for now, plus 2y times the square root of 2x. And then minus 5y times 5 times the square root of 2x is minus 25y times the square root of 2x. Okay, so can we simplify further by adding and subtracting? The answer is yes. All of the terms are like terms. Each of the terms has a factor of y outside of the square root. And inside the square root, each of the terms has 2x. The only thing different are the coefficients, but coefficients, of course, can be different, and they'll still be like terms. So when we combine these, let's just focus on the coefficients right now. 12 plus 2 is 14. 14 minus 25 is negative 11. So our simplified answer is negative 11 times y times the square root of 2x. Okay, now we'll move on to indexes of higher indexes. So this next one involves cubed roots. The cubed root of 16m plus 5 times the cubed root of 54m plus 2 times the cubed root of 40m. The largest factor of 16 that's a perfect cube, or perfect third power, is 8. 2 to the third is 8. The cubed root of m cannot be simplified further. So we will rewrite this as the cubed root of 8 times the cubed root of 2m. Then in the middle term, the largest factor of 54, that's a perfect third power or perfect cube, is 27. 27 times 2 is 54. So the middle term becomes plus 5 times the cubed root of 27 times the cubed root of 2m. And then the third term, the largest factor of 40, that's a perfect cube, is 8. 8 times 5 is 40. So we will rewrite this as 2 times the cubed root of 8 times the cubed root of 5m. Okay, the cubed root of 8 is 2, so we get 2 times the cubed root of 2m. The cubed root of 27 is 3, and 5 times 3 is 15, so we have plus 15 times the cubed root of 2m. The cubed root of 8 is 2. 2 times 2 is 4, so we have plus 4 times the cubed root of 5m. Okay, we can still simplify further. So here's a question. So someone who hasn't answered a question yet, answer this. When we're finished simplifying, how many terms will there be? At the moment, we have three terms. We're adding this plus that plus that. There's three terms. And when we're finished simplifying, how many terms will there be? Okay, yeah, there will be two terms. Notice the third term is unlike the other two. So we can combine the first two by adding 2 times the cubed root of 2m plus 15 times the cubed root of 2m combined give us 17 times the cubed root of 2m. But the third term is unlike that because the radicand 5m is different than the radicand 2m. So this is as far as we can simplify. Okay, the next example involving cubed roots. Simplify the cubed root of 54n to the third. The largest factor of 54, that's a perfect cube, is 27. 27 times 2 is 54. N to the third is a perfect cube because the exponent is a multiple of 3. So we could rewrite this as the cubed root of 27 times n to the third times the cubed root of 2 Okay, then the next term plus 5n times the cubed root of 54. So once again, the largest factor of 54 that's a perfect square is 27. So we will rewrite this as 5 times n times the cubed root of 27 times the cubed root of 2. And then we're subtracting 2 times the cubed root of 16n to the third. The largest factor of 16 that's a perfect cube is 8. 8 times 2 is 16. So we rewrite the third term as minus 2 times the cubed root of 8 times the cubed root. Whoops, I forgot the n to the third. So I'll put that in right here. N to the third is a perfect cube, so we have to have the cubed root of n to the third and then the cubed root of 2. And we'll simplify in the next step. The cubed root of 27 is 3, and the cubed root of n to the third is n. So we get 3n times the cubed root of 2. In the next step, in the middle term, the cubed root of 27 is 3. 5n times 3 is plus 15n times the cubed root of 2. Then for the next term, the cubed root of 8 is 2, and the cubed root of n to the third is n. So minus 2 times n is minus 4 times n times the cubed root of 2. All of the terms are like terms. The cubed roots are identical. They each have a cubed root of 2. And on the outside of the radical, each has a factor of n. So we can add and subtract these. So look at the coefficients. 3 plus 15 is 18. 18 minus 4 is 14. So 14 is the coefficient of the simplified term. 14 times n times the cubed root of 2. Okay, those are examples of adding and subtracting. So just a a quick overview when adding and subtracting. First, simplify all of the radicals as much as they can be. And then if the resulting terms are like terms, you can combine them by adding and subtracting. Okay, we'll look at multiplying radicals. Okay, so we will apply the product property of radicals. If we let n be a positive integer, and if the nth root of a and the nth root of b are real numbers, then the nth root of a times the nth root of b is equal to the nth root of a times b. Okay, so these are examples. Well, there are often two ways to go about it, but I'll give you my opinion about what's more efficient. So one option is to simplify each of the two square roots and then multiply the two square roots after that, and then simplify the product of the square roots. I think the easier way is to first multiply the two radicals by using this property. So in this one, the square root of 12x to the third y to the second times the square root of x to the fifth y. If we just write it as a single square root of 12x to the third y to the second times 3x to the fifth y, and then simplify the multiplication. So 12 times 3 is 36. X to the third times x to the fifth is x to the eighth. And y to the second times y is y to the third. We could write y to the third here, but we know that we're going to be simplifying a square root. So for this one, we can just leave it as y to the second times y. Like I said, it's okay if you write y to the third, but in the next step, you're just going to have to undo what you did because we're simplifying a square root. So another way to say it, the reason I left y to the second times y is because y to the second is a perfect square. And moreover, y to the second is the largest perfect square factor of y to the third. So notice 36 is a perfect square, x to the eighth is a perfect square, and y to the second is a perfect square. So we can take the square root of those three factors. Square root of 36 is 6. The square root of x to the eighth is x to the fourth. And the square root of y to the second is y. And we still have a factor of the square root of y left. So this is our simplified result. Okay, the next one involves the cubed root of 4x times the cubed root of 2x to the second. So we'll write it as a single cubed root, or the third root of 4x times 2x to the second. Then multiply those terms inside the radical. 4x times 2x to the second is 8x to the third. And 8 is a perfect cube, and so is x to the third. So when we simplify, the cubed root of 8 is 2, and the cubed root of x to the third is x. So this time the simplified answer doesn't have a radical in it. It's just the term 2x. Okay, the next one, the fifth root of 2x to the second y times the fifth root of 3x to the third y to the second. So let's write it as a single fifth root. This time I'll just multiply 2x to the second y times 3x to the third y to the second all at once. 2 times 3 is 6. X to the second times x to the third is x to the fifth. And y times y to the second is y to the third. Okay, then we simplify this if we can. The fifth root of 6 cannot be simplified further. The fifth root of x to the fifth can be simplified. X to the fifth is a perfect fifth power. And the fifth root of y to the third cannot be simplified further. So the largest factor of 6x to the fifth y to the third that's a perfect fifth power is just x to the fifth. So we can rewrite this as the fifth root of x to the fifth times the fifth root of 6y to the third. And then the fifth root of x to the fifth is x to the exponent 5 divided by the index 5. 5 divided by 5 is 1. So x to the first, or just x, and then times the fifth root of 6y to the third. Okay, the next one involves a square root, a product of square roots. Okay, the square root of 5x to the seventh y to the fourth times the square root of 45x to the ninth y to the third. So when we write it as a single square root, we'll multiply the radicands. 5x to the seventh y to the fourth times 45x to the ninth y to the third. 5 times 45 is 225. X to the seventh times x to the ninth is x to the 16th. And y to the fourth times y to the third is y to the seventh. Uh, 225 is a perfect square, and so is x to the 16th. And the largest factor of y to the seventh that is a perfect square is y to the sixth. So we could start simplifying, but I'll just rewrite the square root of 225x to the 16th times y to the 6th times the square root of y. And then the square root of 225 is 15. The square root of x to the 16th is x to the 16 divided by the index 2. 16 divided by 2 is 8. So in other words, the square root of x to the 16th is x to the 8th. The square root of y to the 6th is y to the 3rd. And then we multiply 15x to the 8th times y to the 3rd times the square root of y. Okay, a couple of more. The fourth root of 2x to the 5th y to the 3rd times the fourth root of 8x to the 3rd times y. So we'll write it as a single fourth root. by multiplying the two radicands. 2x to the fifth y to the third times 8x to the third y is 16x to the eighth times y to the fourth. 16 is a perfect fourth power because 2 to the fourth is 16. X to the eighth is a perfect fourth power because 8 is a multiple of 4. And y to the fourth is also a perfect fourth power. When we're done simplifying this, we will no longer have a radical. The fourth root of 16 is 2. The fourth root of x to the eighth is x to the second because the exponent 8 divided by the index 4 is 2, and then times y, because y to the fourth root of y to the fourth is just y to the first, or y. Okay, the next one, the cubed root of 3x to the fifth y to the third times the cubed root of 72x to the seventh y to the sixth. Okay, so we write it as a single cubed root and multiply the radicands. 3x to the fifth y to the third times 72x to the seventh y to the sixth. 3 times 72 is 216. X to the fifth times x to the seventh is x to the 5 plus 7, or x to the 12th. And y to the third times y to the sixth is y to the 9th. And now all we have to do is simplify the cubed root of 216 times x to the 12th times y to the 9th. 216 is a perfect cube. 6 to the third power is equal to 216. X to the 12th is a perfect cube because 12 is a multiple of 3, and y to the 9th is a perfect cube because 9 is also a multiple of 3. The cubed root of 216 is 6. The cubed root of x to the 12th is x to the fourth because the exponent 12 divided by the index 3 is 4. And then we also have y to the third. The cubed root of y to the 9th is y to the third. Okay, on the next page, we multiply binomial-like factors. Okay, we know how to multiply binomials, so here we follow the same pattern when multiplying these expressions. So we want to multiply the quantity square root of 7 plus 3 times the other quantity, the square root of 2 minus 5. So we just start multiplying by square root of 7 times the square root of 2, and then minus the square root of 7 times 5, which is, we can write that as minus 5 times the square root of 7. And then we have plus 3 times the square root of 2, plus 3 times the square root of 2, and then minus 3 times 5, or minus 15. And the only thing that can be simplified here is the square root of 7 times the square root of 2, which is the square root of 14, because 7 times 2 is 14. And all of the other terms are different. We cannot simplify any further than that. Okay, the next one, 4 times the square root of 3 plus the square root of 5. Multiply that quantity by the square root of 3 plus the square root of 5. So begin with 4 times the square root of 3 times the square root of 3. 4 times the square root of 3 times the square root of 3. And then plus 4 times the square root of 3 times the square root of 5. So 4 times the square root of 3 times the square root of 5. Then we multiply the square root of 5 times the square root of 3. And then we add the square root of 5 times the square root of 5. Okay, 4 times the square root of 3 times the square root of 3 is 4 times the square root of 9, because 3 times 3 is 9. And then plus 4 times the square root of 3 times the square root of 5 is plus 4 times the square root of 15. And then plus the square root of 5 times the square root of 3 is plus the square root of 15. And then the square root, we're adding the square root of 5 times the square root of 5, which is the square root of 25. Okay, we can simplify still further. 4 times the square root of 9 is 4 times 3, or 12. The two middle terms are like terms. So plus 4 times the square root of 15 plus the square root of 15, we get plus 5 times the square root of 15. And then plus the square root of 25 is plus 5. We can simplify further because 12 plus 5 simplifies to 17. And our final answer is 17 plus 5 times the square root of 15. Okay, the next one, 3 times the square root of x plus the square root of y times the quantity 4 times the square root of x minus 6 times the square root of y. Okay, so just like before, 3 times the square root of x times 4 times the square root of x. I'll simplify a little bit to start with. 3 times 4 is 12. And the square root of x times the square root of x is the square root of x squared. And then minus 3 times the square root of x times 6 times the square root of y. So minus 3 times 6 is minus 18 times the square root of x times the square root of y can be written as square root of x times y. And then we multiply the square root of y times 4 times the square root of x. So that's plus 4 times the square root of xy. And then finally, we subtract the square root of y times 6 times the square root of y. So this is minus 6 times the square root of y to the second. Okay, 12 times the square root of x squared simplifies to 12x. These two middle terms they have like radicals, so those can be combined. So minus 18 times the square root of xy plus 4 times the square root of xy gives us minus 14 times the square root of xy. And then the final term is minus 6y because the square root of y squared is y. Okay, let's work on the next one. 6 times the cubed root of x minus 5 multiplied by the cubed root of x plus 2. Okay, so 6 times the cubed root of x times the cubed root of x plus 6 times the cubed root of x times 2, which is plus 12 times the cubed root of x. And then minus 5 times the cubed root of x. And finally, minus 5 times 2 is minus 10. So on this one, 6 times the cubed root of x times the cubed root of x, that can be simplified to 6 times the cubed root of x to the second. The two middle terms are like radicals, so plus 12 times the cubed root of x minus 5 times the cubed root of x is plus 7 times the cubed root of x, and then minus 10. And we cannot simplify any further than that. So we have a few seconds left. Let's see if we can work on the last one. 5 times the fourth root of x to the third times the fourth root of x is 5 times the fourth root of x to the fourth, and then minus 5 times the fourth root of x to the third times 4. So minus 20 times the fourth root of x to the third. Then we have minus 7 times the fourth root of x, minus 7 times the fourth root of x. And then lastly, negative 7 times negative 4 is positive 28. So there's only one thing left to simplify, and that's the fourth root of x to the fourth, which is x. So we get 5x. The two middle terms are not like terms, so they cannot be combined. So our simplified answer is 5x minus 20 times the fourth root of x to the third minus 7 times the fourth root of x plus 28. Okay, we're out of time. Tomorrow we'll be in the next section, section 8.5. Later today, I will send a test 3 review sheet in an email.